Hi everyone. In the last lectures, we dealt with logarithms to the base 10. Okay. So we had just discussed about logs to the base of 10. So it is not important that you have bases of only 10. You can take any other number as basis also. Okay. So suppose let's take an example. We have 2 to the power 4 is equals to 16. Okay. So this is your exponential form, right? This is your exponential form. So suppose you have to convert it into logarithmic form. So you just have to do the same procedure like we did it with the logs of base 10. So here we'll write 4 is equals to log of 16 to the base 2. Now the base is 2. Okay. So this is your logarithmic form. So there are other bases also other than 10. So when we deal with logs, we deal with a lot of other bases also apart from 10. So let's take an example. Suppose you have to convert log of 49 to the base 7 is equals to 2. You have to convert it into exponential form. You have to convert it into exponential form. So what will be your answer? We know that base raised to the power of exponent is equals to our argument. So 7 raised to the power 2 is equals to 49. This is our exponential form. Okay, so this is very easy. So this is the same thing that we were doing. We are asked questions that suppose you have an expression given in exponential form, so you have to convert it into logarithmic form. And sometimes there are questions which are given in logarithmic form, so you have to convert it into exponential forms. Okay. So let's take another example where we have to find the value of logs. So in the last lecture, we were finding value of logs to the base of 10. Now we'll do some more examples, some different examples. So suppose we have to find the value of log of 81 to the base of 3. Okay. So we know that 81 can be written as 3 to the power 4 because 3 to the power 4 is 81. Okay. So what we are doing here, we are just expressing our argument in the form of our base. Okay. We are just expressing our argument in the form of our base. So log of 3 to the power 4 base 3. So we know when these terms are same, these two terms are same, then the answer is just the exponent. So, or in other words, we know that 3 raised to the power x is equals to 3 raised to the power 4. So what should be the value of x? What should 3 be raised to get 3 to raised to the power 4? So we know that it is x is equals to 4. So the answer of this is 4. In previous examples, we were doing this, but now the base has been changed. Okay, so let's take some more examples. Suppose we have log of 128 to the base of 2. Okay, so we know if we want to express 128, which is our argument, in the form of 2, so we can write it as 2 to the power 7 base 2. Okay, 128 can be written as 2 to the power 7 base 2. So the answer of this will be 7. Okay, so we just have to try to make the base and the argument same. Okay, the base the base number of the argument and the base of the log, we should try to make them same so that we can get our answers directly. Okay, now let's take another example. Log of 1 by 16 to the base of 4. We have to find the value of this. So can 1 upon 16 be expressed in terms of 4? Yes, we can write 1 upon 16 as 4 to the power of minus 2. Okay, we can write 1 upon 16 as 4 to the power of minus 2. So this is log of 4 to the power minus 2 base 4. So the answer will be minus 2. Okay, so these are just the same questions that we had done previously, but the base is not 10. Okay, so sometimes in the examination or in your papers, you are asked to convert some specific expressions into exponential form. You are asked to convert it into logarithmic form. You are asked to convert exponential form to logarithmic form and vice versa. And sometimes you are asked to find the value of these logs. So you just have to make sure that you have to make the argument in terms of the base of the log. Like express the argument in terms of such a power of the base so that the base of the log and the power is equal. Okay, so that you can get your answers directly.